you got a couple of choices on how to do it. First of all, what's the y-intercept? If I want to do y equals mx plus b, and on this particular thing, we can use that as easily as anything. Okay, y equals mx plus b, but it goes through the origin, which means b is what? No, if it goes through the origin, b is the y-intercept. So b has to be 0. Yeah, the origin, both x are 0 and y is 0, or the y-intercept is 0. Okay, so that gets rid of the b. So now we just have to figure out a slope and we'll have our answer. What's the slope if I am going from the origin to the point 1, 2? It's the slope of that line. Going over 1 and up 2. Yeah, I didn't draw it right. It's rise over run, so it's 2. So that means the equation of that line is that. So that's relatively simple and straightforward. Now, I could also have used, I could also have used point slope. You familiar with what point slope is? Well, tell me if you've ever seen it. We may end up using it here because, maybe not. You can almost get away with, okay. It's just a different format. The way to memorize this is divide both sides by the x minus x1, and you got slope equals rise over run, right? So that's the way to memorize it. You know what slope is. It's rise over run. Well, divide both sides by this amount here, and you got slope equals y minus y over x minus x. That's rise over run. So that's the way to memorize it. And as far as applying it here, we know that y sub 1 is 0, because we're going to use that point. And the slope, we're going to calculate that it's 2, because it goes up 2 over 1. And x sub 1 is 0. So you end up with y equal to x. Same thing. It's actually a little harder to use point slope than it was to use this method. Y equal mx plus b, the only thing we needed was the slope, because b was clearly 0. All right, let's go forth here. Yep, that's the definition of it. It's where the x and the y-axis cross. All right, number 6. An apartment building contains 12 units consisting of 1 and 2 bedroom apartments that rent for $360 and $450. Immediately, I jump to the last sentence, which is what's going to define my variables. What is the number of 2 bedroom apartments? Whenever you have a word problem, the first step is to define your variables. We got 1 and 2 bedroom apartments. So let's let x equal the number of 1 bedroom apartments and y equal the number of 2 bedroom apartments. Okay? They only want to know the number of 2 bedroom apartments, but we need to allow for the 1 bedroom apartments in order to solve it. Okay? Now, the first thing I can say is x plus y equals 12. Right? Tells me there's 12 units in this apartment building. Second thing I can say is that the number of 1 bedroom apartments rent for $360. So that's the income you'd get from your 1 bedroom apartments if you were the landlord. This is the income you would get from your 2-bedroom apartments, 450 times the number of them you have. And we know from when all units are rented, the total income is $49.50. So there's our 2 equations and 2 unknowns. You can almost always solve for 2 equations and 2 unknowns. Okay? When I say almost, we'll do it. But every now and then you'll run across 2 equations and 2 unknowns that don't have a solution or has an infinite number of solutions. But all the problems you're going to get on this test almost always will have a specific solution. Okay? Now, there's 2 ways to solve simultaneous equations. There's substitution and there's elimination. Which should we use here? Okay, when your equations are in standard format, and they are. Standard format is where your x and your y are on the left and your numbers on the right. Okay? Both of these are no, that's the perfect case for elimination. Okay? Well, that's okay. And the only rule I have is that I can add or subtract the 2 equations, or I can take one equation and multiply both sides by any number I want, and then add that to the other equation. Well, my goal here is to eliminate a variable. And since they're asked, okay, well, I'll go through it here. It's a little harder to understand on problems like this because the numbers get big, but that's okay. If I multiply, here, let me number these. This is number 1. This is number 2. Okay? I'm going to multiply number 1 by minus 360. Both sides. Any equation, you can always do that. Okay? Number 1 becomes minus 360x minus 360y equals, do you have your calculator handy? Okay. You can use it. You can use it on this test, incidentally. The TI-84. At least, well, actually, I shouldn't say that. You could use it on the math placement exam for Colorado State University. I haven't read the directions on your Accuplacer yet to know that you got to be able to use it. I can't imagine they wouldn't let you use it. So what's 12 times 360? How much? 12 times the number 360. Can you hear me? And the negative sign is in front of that, obviously, because it was negative 360. Okay. Now, I'm going to deal with these 2 equations next. Notice, if I add those 2 equations together, the x variable disappears. It gets eliminated. That's why I multiplied equation number 1 by minus 360, so that it would go away. And multiply it by 370, or 359, or 361, multiplied it exactly by 360, so that I would end up with a negative 360x, because I already got a positive 360x. So now I'm going to add the 2 equations together. The x's go away. I got, no, I'm taking equation 1 and I'm changing it. I'm multiplying both sides by minus 360, and then I'm going to use that result with equation number 2. This is part of the process. You have to do this with elimination. Okay? And now by adding the 2 equations, x goes away. See, if I'd have added the two equations without doing that, I would still have 359 or 361x. You've got to get one of the variables to be eliminated, hence the name. Okay, now I got to add the right side also. What's that come to? 630. Okay, now I got 90y equals 630, y equals 7. That's how many two-bedroom apartments there are, is 7. And that's all they didn't even ask for how many one-bedroom apartments there are, but clearly there are 5, because there's 12 in total. With me? All right, I'm gonna minimize this for a moment, and I'm going to give you another elimination problem because these are hugely important. Only this one I'm going to make this one a little simpler, just so the numbers don't overwhelm. Okay, let's say you have these two equations. And over here you have 2x minus 5y equals 5. Now those two equations are independent from one another, which means we should come up with a unique solution. But notice I cannot eliminate a variable. If I add the equations together, I get 3x and 4y minus 4y. So I don't eliminate. So in order to eliminate a variable, I'm going to take the top equation and multiply it by what? I'm trying to eliminate, and I don't really care which variable, but let's say I'm trying to eliminate x. Yeah, so I'm going to multiply that by -2 and the right side by -2 also. And now I'm going to rewrite that equation. Originally it was number 1. It's still number 1. This is number 2. Well, -2x, it's -2x minus 2y. You don't say plus minus, you just put the minus, equals -20. Okay, and I'm going to run a line through that because that's no longer my equation 1. Now I have these two equations. Now, notice, what do I have to do in order to have a variable go away? Yeah. And incidentally, you can add or subtract. So I didn't necessarily need to multiply it by -2. I could have multiplied it by +2, but then I would have had to subtract. Problem is, most people have more trouble subtracting than they have adding. So generally, you set it up so that you can always add. Okay? Well, it's just easier, and if I add those, but it doesn't matter. In other words, if the equation comes ready-made so that you can subtract it, do so. In other words, if I have this up here, yeah, don't do anything. Just subtract the equations. I don't have to multiply it by anything. No. In other words, if it comes ready-made, but notice it's not so easy to subtract. What's the y term? It's -5. Well, that's different than 5. And that's okay. But therein lies the problem. Everybody has a little bit more difficulty with subtraction than they have with adding. So that's why, in general, you set it up so that you can add the two equations, not have to subtract them. Sometimes they get handed to you on a silver platter like this one. If you were given this problem, you wouldn't bother to multiply one side by -1 so that you could add them. You would just go ahead and subtract them. Just be careful. Notice y ends up 1, which isn't bad. I got a whole number, and I pulled this one right out of thin air. Okay, so that's how you use elimination to solve simultaneous equations. Okay, now, just to be clear, there are some where you have to multiply both top and bottom. That's equation 1. This is equation 2. Yeah, exactly. You find a least common denominator. So I'm going to multiply the top by 3 and the bottom by 2 so that I'll be able to eliminate the x's. And just to turn it into an addition problem, let's multiply the top by minus 3. And the bottom still by 2. Okay, that gives me 2 new equations totally. The top one is minus 6x minus 9y equals minus 30. The new number 2 is 6x minus 4y equals 10. Now I can do a very simple add. Don't even write it. I get minus 13y equals minus 20, and I have solved for y. Y is 20 over 13. Once you solve for one variable, you go back into your simplest equation, substitute it, and then you can solve for x quite easily. Okay? So that covers elimination, pretty much. That's the most complicated case you're going to run into, where you have, well, substitution would be if you had something like the following. You don't have it, yeah, this is going to be a substitution problem. Notice the bottom one is in standard format. The top one is not. The top one is solved completely for y. Since it could, but that's extra math that isn't necessary, so let's use substitution. These are the problems where you would prefer to use substitution. In other words, I'm going to take what y is equal to, and I'm going to substitute it into equation number 2 wherever I run into y. Well, there's a y. Let's put in 2x minus 2. That's it, yeah. Notice, now I have one equation with one variable only. I will be able to solve for x. In fact, I think I end up with 11x equals 18. So x equals 18/11. Okay, so substitution is when one of your equations is fully solved, and it doesn't matter for y or x. If they would have given us x equals 6y minus 7, I'm going to use substitution because x is fully solved. And I'm just going to go wherever I see x and substitute 6y minus 7. So the names really tell you how to do it. Substitution is exactly what it means. You're going to substitute. Well, you're substituting what y is equal to for y in the other equation. All right, let's get back to your questions here. When do you take this exam? Oh, Jesus. Well, I said that a little bit facetiously, in that there's a lot of material to cover in these things. There really are. So we're not going to get through it all at the pace we're going. Okay. I'm seeing some problems here that look pretty standard. Okay, how about number 7, upper right? Go ahead and read it. Well, it's true they used difficult numbers. They didn't use simple numbers, okay? So tell me what the side of that square is. About square root of 125. That's the distance from there to there. Because you get the area by multiplying, by squaring a side. When you have a square, you get the area of the square by just multiplying the side. So if they give you the area, you take the square root of it, and that gives you the side length. Okay? What's this side length here? So my perimeter of both regions are 4x plus 4. In other words, 4 times that for the bigger square plus square root of 5 for the smaller square. Okay? Now, that's our answer. The reason you don't see it on the answer list is because I haven't simplified the first number. Let's simplify square root of 125. Factor it where one of the factors is a perfect square number. The way you simplify this radical, no, that would be 3 times what? 3 times what? And the 3 is not a factor of 125. Yes, what you need to do is find, okay, I'm going to, over here on the left, I'm going to list the perfect square numbers. What you want to do is find a factor of 125 that is preferably the largest perfect square number. Are there any numbers in that list that's a factor of 125? 25. Correct? 5 times 25. If you have 5 quarters in your pocket, you got $1.25. No. Jesus. Sam? Okay. We got cut off right. We got cut off right in the middle. Okay, that's okay. Let's talk about the first one again. This side length. Hold on. Unfortunately, I had to erase everything. This side length is root 125. Let's forget about the other one for a moment. Let's simplify 125. That is 25 times 5, and 25, square root of 25 is 5, so it simplifies to that. Okay? That's one side. So let's erase that and call it 5 root 5. How many sides are in that? 20 root 5. If I'm multiplying that by 4, I only multiply the 4 by the first number. So all 4 sides are 20 root 5. This one down here, one side is root 5. All four sides are 4 root 5. They want the sum. So I got 20 apples. Right, I got 20 apples and 4 apples. I got 24, and my apple is a root 5. That's your answer. That's your answer right here. No, this is a pretty simple problem, but it does involve you, it forces you to simplify a radical. Because otherwise I would have been trying to add root 125 to root 5. You can't add those. One's an apple and one's an orange. So I've got to simplify the root 125 before I can add it to the other one. So it's a little harder than it looks, just because it requires you to simplify. Okay. All right, logs. Let's talk about logs. Well, no, logs really aren't tough. You just got to memorize a few things. Yes, it is. No. You were close. It's not 3 to the 10th, it's 10 to the 3rd. In other words, you take the number on the far left, you raise it to the power of the number on the right, and it's equal to x. So you got 10 to the 3rd equals x. Well, 10 to the 3rd is 1,000. So it's B. So this was really a simple problem. You only had to know how to do one thing. Convert logarithmic expression to exponential expression. Let's just make sure you know how to do this. Convert that to exponential. Let's make it just a little bit easier. We'll make it 2. Okay. So what is it? Keep going. Now you can solve it. In other words, you had a log. Exactly. 48 equals x. So the key to solving log problems is being able to convert them to exponential. That's all there is to it. Because then you have numbers. Then you have an algebraic expression that you can solve, as opposed to a logarithmic expression that's much more difficult to solve. All right, let's go down. The next question deals with composite functions. Number 9. Exactly. So, well, it's always good to start from the inside, okay? So we're going to start with that right there. Here, hold on. What is g of x? It's x minus 1 over 2. So that's what I'm trying to figure out, is what is f of x minus 1 over 2? Well, we have the f equation right there. If I have something in the parentheses, how do I solve it? By substituting it. Here, let's start from the beginning, because this is really important. Take a look at the f of x equation. If I said to you, what is f of 3, what is it? Yes, if I said, what is f of 4? What is f of x plus 1? Yep. In other words, the rule is whatever is in the parentheses, you substitute for x. Okay? Now, what we had was f of x minus 1 over 2. So that's what we have to solve. So we want to be very, very precise here in how we do this. Where I've run into an x, so what I'm going to do is put parentheses. Well, the parentheses are the most important. There's no order. You just go to the f equation, and wherever you have x, you substitute what's in the parentheses. Okay? So that's what I got right there. Now, if I simplify that, those cross out, my minus 1 and my plus 1 crosses out, and I end up with x, which is answer A. Now, there's a curious thing that's worth knowing. If f is the inverse of g, then the composite function will always equal x. So we just solved the composite function and we got x. And what that tells us is that the f function is the inverse function of the g function. And also, if I were to have done this, in other words, put the other inside, that's also going to equal x. And what I would have done there is I would have said g of, what's f of x? 2x plus 1. Now, how do I solve that? I go to the g function. Now, wherever you run into x, you plug in 2x plus 1, and you can see that it's going to turn into just overall x. So both f of g of x and g of f of x were both equal to x, which proves that they are inverses of one another. Even though this problem did not ask you anything about inverses, that's still a fact that's worth knowing when you're dealing with composite functions. Because they may ask you to solve for the, there's an easier way to solve for the inverse than doing that. But we'll wait and see if we get problems like that. See, most of these aren't that hard. Just that third one was a strange one. I've never seen anything quite like that in problems dealing with imaginary numbers. Okay, so number 10. How's your trig? Okay. The most important refresher you can get on sine and cosine are these 30-60. And 45-45. That will answer all of your basic angles. Well, the key here, no, that's isosceles. It's not equilateral. No, it's just isosceles. Right. The key isn't what I've drawn. The key is the dimensions. Okay, that dimension is 1, this dimension is √3, and this dimension is 2. And over here on this triangle, that's 1, and that's √2. So take a picture of those two triangles, memorize them. Because if I said to you, what's the sine of 30 degrees? And if you forget SOHCAHTOA, memorize that also. You cannot, yep. So they're telling you the sine of theta is 1 over 2, so theta must be 30 degrees, right? Right? In other words, if the sine of theta equals 1/2, and we know that the sine of 30 degrees equals 1/2, then theta is 30 degrees. That's right. That's right. The only angles that you have to really memorize are the 30, 45, 60, and multiples of that. But mainly you just need to know the acute ones, the first quadrant ones. And you can get all of those off these two triangles, What's the cosine of 30 degrees? I've already figured out that theta has to be 30 degrees. You got it. That's how you do these. There's actually another way to do this that's probably a little simpler. Yeah, no, you got that. That's what cosine of theta is, square root of 3 over 2. Because we know theta is 30 degrees, yes. However, the only reason I suggested this method was because I want you to memorize those triangles. Memorizing those triangles and their dimensions will allow you to answer all of the trig functions that are in the first quadrant. In other words, up to 90 degrees. Like, what is the tangent of 45? What's the tangent of 45? That's it. That's how you do it. So you can figure out the sine of all three angles. You can figure out the cosine of all three angles. You can figure out the tangent of all three angles. And you can figure out the other three trig functions because they're just reciprocals. In other words, if the sine of 30 degrees is 1/2, then the cosecant of 30 degrees is 2 over 1. Okay? So either memorize your first quadrant common trig functions angles, or memorize these two triangles so that you can always figure it out. All right, let's go on. Let me check the clock here. We don't have a whole lot of time. We've got about 5 minutes. Yeah, no, in fact, these are getting progressively easier as we go down. Number 11. There's no x in number 11. Yeah. It's simplifying, and then look at all the answers. It's not just simplifying. Oh, there's actually a trick here that you have to spot. Look at this line right there. Now, just look at that line. Is there a greatest common factor? Well, greatest common factor means, is there anything that I can divide into that and that? Both of them evenly. Yes. You're not used to seeing greatest common, no, hold on. So the answer, I'm going to factor out a 2y minus 3. And what's left over? 5y plus 1. Remember, I got to divide that by 2y minus 3, and I got to divide that by 2y minus 3. That's what it means to take out a greatest common factor. Okay? So, yeah, we do. That's got to be an answer on there. It's this one right here. In other words, this was the easy way to do it. This was a single step. As opposed to multiplying it out, getting 10y. No, if I were to distribute that, I get that, and then I got this, and I get that, and then I got to take that thing, simplify it, and factor it in order to get our answers that we got. That's hard to factor. That's not going to be easy to factor. If I start with 10y squared, combine my y's, I got minus 13y minus 3. That might take me 10 minutes to factor. That's a hard thing to factor. First of all, I don't know how the y's split up. Is it 10y and y, or is it 5y and 2y? Nonetheless, it's a difficult factoring problem. You'd eventually, yeah, exactly. They give it to you so the people that recognize. Where you have used this before is when you have solved cubic functions by grouping. Remember doing that? where the only way that you have learned, I believe, no, you might have learned the rational factor theorem also, but the typical way they teach you how to solve cubics is they give you one that can be grouped. And when you group it, you end up taking out a greatest common factor that is a binomial term. Notice that normally we take out monomial terms when we're factoring, right? Your whole life, that's all you've taken out. And here we have a situation where we're actually going to be able to factor out a binomial term. Well, yeah, no, I mean, there's the 5-second solution here, and then there's the 5-minute solution. So it really makes a huge difference as to which technique you use and whether you recognize that, ooh, I can factor out a 2y minus 3 right off the get-go, and I've got my answer. All right, let's stop there at number 11. And I'm more comfortable now that we're in the right realm. In other words, I don't feel like we're on well, yeah, problem number 3. The problem was the first time through I gave up the moment I saw it had imaginary solutions. And then after I got off the phone with you, I decided, well, I'm just going to go ahead and solve this whole thing with the imaginary solutions, and I realized, when it's squared, you lose the I, and you end up with a negative number. So it was tricky, but most of them are not. Most of them we're running across here are very standard questions you would get in a high school math class. So I feel much more confident that we're in the right section. I wasn't so sure at the beginning of this conversation, but after working through 11 problems, I am now. This is where we want to be. Okay? All right, and I will talk to you Friday. I think you have the session. You want to move it back while we're on the phone here? Hold on. You're at 6:30? All right. Text me if you think you're going to be late. That's all you need. Thanks. Sounds good. Sam, I'll talk to you Friday night at 6:30 or shortly thereafter. Have a good evening. Bye-bye.